Hello and welcome back to another episode of From the Field. If you haven't noticed, we have updated or changed our intro, or the one just giving a heads up that the stream is going to start. I spent way too much time and effort on that thing, mainly because the old one, yeah, it is like kind of like the movie trailer. It was put together in the moment of passion. Um, I kind of Yeah, it probably needs a few tweaks, and like I definitely paid for one of those sound bites, but hopefully it's worth it. Hopefully everyone enjoyed it because the old one actually used to say that we start at the top of the hour, which was about 30 minutes off the point. So yeah, I'm glad you liked it such a bite. Um, yeah, it made it well worth it, and it also crashed my computer like multiple times because I was just like duplicating stuff, and I think the JavaScript couldn't handle it. Anyway, yeah, I'm your host, Casey. Also, I'm a solution architect based out of Wellington, New Zealand. If you can't see in the background, I'm in the office today, not in my lovely house studio. And we got Pecky in the background, just so you know, something's always smiling at you. It's kind of interesting a character. But anyway, I won't fixate on that. With me, I also have Vish, who is another solution architect located in Auckland. He'll introduce himself. He's just here. Yeah, just here for the opening, and then then bailed. Yeah, it's all downhill from here. Like there's no awesome music video or film from there. The Yeah, so we're going to go deep diving into analytics, and how do you make sure that all of the data is going that you're building your analytics off is like high, filtered and is in good quality and all of that stuff. Vish will go into that. He's part of the TFC, which is a focused community within AWS. So he's very, very knowledgeable on that front. And yeah, I think with that, I will hand over to you, Vish, to do an introduction for yourself.
Thanks, Casey. Good afternoon, and hi everyone. My name is Vish. I'm a solution architect based out in Auckland. I work with the enterprise segment and mainly look after financial services industry customers, banks, insurance, and help them with cloud adoption, digital transformation on AWS. By the way, I'm jealous. Casey, you got a very good background.
The one at home is just like a white wall. I'm like trying to buy like the neon sign that so
Yeah.
it can like just flicker in the background.
Yeah, I used to have a very plain background thanks to one of my colleagues who recently presented a nice plant to me. And I thought, maybe my office studio is a good place to keep that.
Apparently, like plants are supposed to increase productivity. Like that's why you see them around in like the offices and stuff like that. And then like on fair inspection, all plastic. So I don't really know how that works in the long term. But yeah, it's just kind of like the one where you take the research and then be like, oh, actually looking after plants is a pain. So we just won't do that. But if there's plastic, it's like it all works the same, right?
Yeah, absolutely.
Cool. So what are we going to be going through today, Vish?
So I'm going to talk about data quality because data quality is very, very important, right? And data comes from all the sources and all its life cycle, and it's really important to do the data quality checks before it reaches to the destination, whether it's a production systems, whether you're machine learning, models, or even when you're doing analytics on top of it, right? And there are quite a few challenges I've seen in my customer space, especially getting started with the data quality. And that's where I'm going to talk about a couple of open source libraries that we built internally within Amazon for our own internal use, and how we made, that is now available as open source, and how you can use those open source libraries part of your data pipelines in various use cases, helping you come up with those data quality checks, making sure that it's not time consuming and we do all the heavy lifting for the customer. So really, really excited to talk about those use cases, as well as I have a small little live demo. Hopefully it works, fingers crossed. But yeah, I'm keen to show how data quality can be ingested into the data end-to-end value
Yeah.
pipeline.
All live demo is going according to plan. So, I'm sure there'll be no drama on that front. Yeah. And on that data quality front, yeah, one of my older jobs, we're storing sale prices of transactions that go through like e-commerce stores, and one of the oversights we had is that we wasn't actually transforming any of that data into a common currency. So and then trying to do any analytics over that was an absolute nightmare, because you always would have like the Vietnamese dong
Yeah,
come in and this like be like, yeah, this piece of furniture is worth like $20 million, and then you'd look at it and be like, that's a bit odd. And then
yeah,
you'd and because they interchange between the US dollar and the Vietnamese dong over in Vietnam, because
yeah,
so that was fun.
absolutely.
So do we
Cool.
have a presentation for us?
Yeah, I have a presentation and as well as I have a live demo. So let me quickly um, pull
Oh,
my.
we got Inception.
That's fine. I think it should be fine now.
This should be fine.
Cool.
There
So
we
I
go.
have few slides and also I'll have a live demo at the end. So I'm going to introduce a couple of open source libraries, as I said, DQ and PyDQ, and literally talk how that can help you with your data quality checks. And at the end, we'll build a serverless end-to-end data pipeline, integrating these open source libraries and see how that works in action, right? Um, Before we start, so I come from application development background. So we all write unit tests, right? And it's like a standard practice. And it's really helpful, especially finding quality of your code, any bugs very early in your the deployment pipeline. So it's very good. But do we do the same thing for data? Perhaps not to that level, right? And couple of reasons, a lot of my customers do the data quality checks, but it's like an iterative process and it takes a long time and takes a lot of time and effort to come up with all the data quality rules and data quality checks to implement that or identify it, especially if you have a large data set, multiple columns. So data stewards and data owners needs to go through the data and identify, okay, this data requires these quality checks based on our business requirements. And that's where I've seen the starting point is always delayed because huge data, a lot of time required. And in some cases, you may not have entire context behind the data because, as I said, in an organization, data may be coming from third-party providers or partners. It might be coming from multiple data sources, your databases. It could be coming from your on-premise in hybrid scenario, as well as coming from your data lake, data warehouse, name it, right? So data comes from everywhere, and typically you get large set of data. And way to get started, right? That's where I've seen the writing unit test for data is always cumbersome and take as a back burner. Most of the organization, as I said, do that in like an iterative process. For example, I'm a data scientist or engineer for a particular business unit. I run the reports and I come back to the data owners or data stewards saying that, hey, Casey, currency is not correct. Then as a data owner, you go back. Sorry, go ahead, Casey, if
I
you.
was gonna say that my data's always correct. It's obviously your report's wrong.
Absolutely. But if you are a friendly data owner and a data steward, then you go back and apply those rules part of your data. And when the next time the data comes, it validates and does that. Now, imagine doing that all the time, coming up with a good, a solid unit test for your data is going to take ages, right? So that's where DQ really comes in handy. So DQ is open source library built on Apache Spark, and the key use case is basically writing unit tests for your data and measure your data quality against those data quality constraints or suggestions that it comes up with, right? And as I said initially when we started the introduction, it is internally developed by Amazon Research for our Amazon.com data, and we heavily use that today. And in 2018, we made it available for our public as an open source under AWS Labs and GitHub, and you can start using it today. And if I look at like 10,000 foot view without going into the details, so two key aim behind developing DQ is, first of all, automatically coming up with a set of unit test or data quality suggestions for your given data set. And it can scale up to billions of rows, right? It can handle any size of your data. You just have to give your data, and DQ will come up with set of initial tests or initial suggestions for you. And
So this
second,
would be, sorry, so this would
mhm,
be like a tool that would you'd use to build confidence in your data set. So when you actually start doing those initial reports and presenting them to your leadership team or to the C level, for example, then they can, they can. They have that trust off the bat where I know I've seen a lot of data projects fail at that stage. So I've built up the data, like give it to the CEO or whatever, and they were like, no, this is wrong. And then from there,
absolutely.
it's an uphill battle again. So this is kind of like, preempting that.
Absolutely right. And data quality is important. As you rightly said, some of the things, let's say a null value suddenly comes and your production system is down, right? If the code is not handled correctly, or maybe people making some data driven decision, and if the data quality is not there, you're always in two minds. And I've seen a lot of times, especially in big organization, when you have multiple business units sharing the data, the first thing I hear is we really can't trust this data because data is in multiple sources, there is duplication of data, and master data is also doesn't match. So how we can test the quality of the data, right? Where do we get started? And that's where DQ comes in handy. At least it will give that boilerplate template or starting point so that you give your data and it comes back with set of suggestions for you. It does the initial heavy lifting rather than you having to do that your own. Uh, and once the suggestions are there, the DQ also calculates quality of your data against those rules or against those tests, right? And as I said, it's not a tool, it's not running somewhere, it's just a library. You can integrate that part of your Spark code as you are integrating any other open source libraries, right? I'll show you how you can use that when we are doing the demo. Just on version and its evolution, as I said, it's publicly made available in 2018. The latest version is 2.0.1, and for that you need to have Spark 3.1 version. But if you have a previous Spark version, don't worry, you can always use previous version of DQ. That is 1x, right? And there is
Can
a
you
link
easily
on.
use it? Sorry, can you
Mhm.
easily use it in Glue, or do you need like to use an EMR?
You can easily use it in Glue, and I'll have a slide where various use cases. In fact, my demo is going to be on Glue today. Yeah.
Oh,
Cool. And there's a link on the bottom that should take you to the DQ GitHub page, and you should be able to look at all the details around the component or the library. Now,
And
yeah,
chat, feel free to chuck in questions and derail us if you want to know more about certain aspects of it. Like this is not a linear one. Like we actually kind of want to make sure you're learning what you want to learn and get out of this. So yeah, don't be shy.
thanks, Casey. And if there are any questions, just interrupt me, Casey. I can't see the questions when
Will do.
presenting. Yeah. Now, you might have a question in your mind how DQ does. And I said it does a lot of heavy lifting upfront for you to get you started with your data quality testing journey, right? So let us dive a little bit deeper into the architecture of the DQ. Mainly, it has four components. So it starts with the first components called metrics computation. We also call that as a profile scanner or profile scanning. So what it does is when you give your data to DQ, it scans your data, entire data set, and for all the columns, it comes up with the base statistics, right? When I say base statistics, it checks in three different parameters: completeness, consistency, and other statistics, right? So to name it, in the completeness, first of all, it checks what is the data type of the column, whether it's a string, integer, computed, any other column types, and start looking at the data and identify, hey, data should not be empty, it should not be null, and those kind of suggestions it so those sort of statistics it start collecting. Second thing it also does, it looks at the data and looks at, hey, does the values fall in certain range? Let me give an example, right? So if you have a column called priority, as part of the scanning process, it looks at all the data has a values either high, medium, or low. So it creates kind of a stat that, hey, there is a range for my values, which should be falling only within this set of data range. It also checks some of the statistics around, if it is a number column, it checks what is the min value, what is the max value, what is the average value, and all those things. So if you look at it, metrics computation, it's nothing but it looks at the data, scans the data, and kind of comes up with a base profile stats for your columns. You'll understand that bit more when I show a few examples, right? So imagine that it's understanding the data, and DQ is understanding your data set. And once it's understood, that's where the second component kicks in and looks at your profile data and identifies some of the initial suggestions rules for you. Right? It comes up with those unit tests or data quality constraints for your data set. Now, this is a game changer when I use DQ, right? As I said, for data owners and stewards, always starting point is difficult, right? So where to start, what all the data quality I need to begin with. So you could use DQ in this case to get started, see all the suggestions that DQ is giving. Now you don't have to use all of them, right? You can discard few of them, modify them, or add any your own rules on top of it based on your business requirement or your data context. But at least it will give you a very good boilerplate template to get you started with, right? And once you have the profile data, once you have the suggestion, that's where the third component comes in handy, which will go and check your data against those suggestions and say that, hey, what is your data quality looks like, or whether they are meeting the requirements, right? And while doing so, it generates a lot of data for you, like reports or outputs. For example, your stats, as I said, verification results. And as an organization, it's a best practice to keep that in a central location. And that's where you can use fourth component, where you get all the results from the DQ and you can pump it into your favorite storage. It could be Amazon S3 or could be sending into a database, but making it in such a way that you can reuse that later on for your reporting and your analytics purposes as well. So that's how it works, Casey. Any questions on the comments, or you have any questions on how it works?
No, it sounds like you've been crystal clear so far. And yeah, I don't have any comments. I'm actually kind of very interested in the demo now.
Nice. So just another view from a data pipeline perspective. Let's say you have built an end-to-end data value pipeline or ETL processing pipeline. And if you look at the square there, that is where we integrate DQ, right? Imagine a data producer is sending a data to your data lake or to your data warehouse or any location. That's where we start DQ processing. As I said, DQ does column level stats. It does the identifies the constraints or identify the unit test for your data and verify the constraints, right? And now you have flexibility in your downstream data pipeline, that whether you want to send a notification to the producer, hey, there is errors in the data quality, or you want to stage the data before sending it to the production, or you can do any steps. You can take any step as part of your pipeline. So hence why it becomes really powerful to use DQ anywhere in your data value pipeline. And I'll talk about different use cases as we go ahead. Perhaps an example makes things always clearer. So I'll use an example here. Now, you might have a question that, hey, what sort of data my DQ library supports, right? It can support any tabular data that you can load onto a Spark data frame. In other words, whatever the data that you can today load on a Spark data frame, you can use that with the DQ. So whether it is a CSV files, whether it is your log files, whether it is your flattened JSON files, or even database tables, all those can be used with DQ to come up with those data quality checks. Now, here is an example, a very simple example of employee record set in an organization, right? So a list of employees who joined when and things like that, right? And imagine if you are giving this data to DQ as a first step, it goes and comes up with all the unit test or the data quality suggestions. Let's take a few examples so that we start making sense, right? So first name, it looks at the entire data set and saw that, hey, all the data, first name is value is there. That means it cannot be null. So it has made the decision and come up with a rule or a unit test or a constraint saying that, hey, first name should be complete or should not be empty. The same time, if you look at next column, which is age in company years, it's a funny column name. You can say experience. So it's saying that it's identified as a number or integer column, and it's saying that it cannot be empty or null. Plus, it cannot be non-negative. It also looked, I mentioned about range or consistency, right? When I talked about constraint suggestion. So if you look at day of joining, it looked at the record set and said that, hey, most majority of the rows having values between Monday to Friday, which is weekdays. And it kind of come up with the rule saying that, hey, the value should be falling between Monday to Friday, right? And so on. It also comes up with email formatting and so on, right? It does all of those things. So just to give an example. And once the suggestions are generated, and the verification component or the third component runs and start analyzing your data and identify whether the rules have been passed or failed. And based on that, you can take different paths. As I said, you can notify back to a producer, or you can stage this data in a staging area before you sending it to the production, right? If you look at first row, it says that it's failed, and the reason
I
is
was sorry, Vish. I also noticed that it generates regex. If I saw the other slide correctly, so that's a lifesaver. Regex is an absolute nightmare to have to build yourself.
absolutely, absolutely. Plus, it also does what we call intercolumn relationship. I'll give that example. I think it will wow you, and it's one of my favorite features of DQ, right? So if you look at quickly completing the results here, the first row, it has said that, hey, there is a rule is failed because day of joining is Sunday here for that person, and it's identified that as an anomaly that uh, expected is Monday to Friday. Again, its suggestion, data owner and data steward had always a flexibility to change this, modify this, just a starting point for you. At the same time, it looked at the majority of the ID columns and saw that, hey, ID column has to be in particular format. As you rightly said, the regex, and some of the columns are not matching that. It has raised that as a anomaly. Now, to coming back to your question, this is only basic example. It goes really deep, Casey, and it's really complex, right? It has multiple steps, multiple permutations and combination, and the algorithm is very complex. And hence why I said initially, it really does heavy lifting of not having you to write those algorithms for your data quality, right? So for example, it can correlate two columns and identify anomalies. For example, in this case, if employee experience is going up, and expects that base salary also should be going up based on the patterns in the data set. Suppose there is a record where the experience is high but base salary is below the average, it can identify that as anomaly as well, which is cool, right? So those kind of things it will do by looking at the data. So this is DQ. As I said, it's open source, built on Apache Spark, helps you with your data quality constraints and checks. Now there is a PyDQ. It's exactly the same as DQ. It's just a wrapper, Python wrapper around DQ component. It's just to make sure that if the data scientists and engineers who are familiar with Python and prefer to work with Python as a language, it's just a wrapper around that, so that those people can interact with DQ using Python language or Python APIs. It's as simple as that. And typically, I've seen that PyDQ is mostly used in SageMaker and your machine learning space, where that is where you mostly write your models and notebooks using Python as a language, and you use PyDQ as a library as opposed to DQ.
Yeah, I generally use Python for anything related to the machine learning or Glue, like Hadoop ecosystem is just all Python for me.
Absolutely. Now, adoption of both DQ and PyDQ is growing. As I said, it's very popular, one of the popular open source product by us, and a lot of people are using. And we smashed this library in our own internal use, right? Amazon.com data quality is all checked using DQ and PyDQ. I talked about use cases. Since it is an open source library, you have both Spark support as well as Python support. Now, use cases are endless, right? So whether you're talking about migrating data from your on-premises into cloud, and as you're migrating, you want to test the quality of the data, go for it. Or you're getting data from your partners or third-party providers, and you want to do that, quality check before that gets into your production or maybe your data lake, you can do that. Casey, you mentioned about data processing. Whether you're doing big data processing using EMR, again, you can easily integrate part of the data pipeline. Or if you're doing using Glue, writing that ETL pipeline for your extract, transform, load, as part of that, you can also easily integrate DQ as a library for your data quality. And that's going to be my demo. So next is, I think, the part where you're really looking after forward for, Casey. Hopefully that works.
Yeah. I
Mhm.
Yeah, I'm really looking forward to the demo. Like I always like a good live demo, a bit of drama.
Cool. So I have built this demo based on a blog post, and for all the audience here, you can easily go through this blog post and download the cloud formation and try out entire solution in your environment, right? It fairly one-click deployment takes 1 or 2 minutes to deploy everything. But I'll tell you a little bit of architecture here, what's going on before jumping into the demo, right? So what we built is a data pipeline using Glue, and whole idea is to check the quality of the data that we have. It's a sample data. So what we have done is we have created three. Casey, give me a thumbs up if you can see my pointer as well, mouse pointer.
I
Cool. Okay, so we have written three glue jobs, and the first job is does that profile scanner using DQ, and once that is done, then the second job will go ahead and generate the suggestions or the data quality unit test for you. And third glue job will do the verification. Now you could do this in a single glue job. It's just the best practice that you separate each activity in its own component, right? That's how it is separated out. And the data, the results, as I said, you have full flexibility to store it in your single pane of glass, whether it's a S3 bucket or any other database, you could do that. And that's where we are sending everything to S3 bucket, all the results from the DQ, so that you can use services like Amazon Athena for ad hoc queries later on, if you want to do any analytics on top of it. We're also sending the data to DynamoDB, and the reason we are doing that is we built a small user interface, a UI on top of all this solution. If you remember, I mentioned that DQ comes up with initial set of rules or validations, and data steward or owners can modify that, disregard some of them, add their own rules, right? In order to make those steps easy, we just given a user-friendly interface, right? That's the whole purpose of sending the data into DynamoDB. Now, entire glue jobs are orchestrated using a step function. And you could, in your environment, use Apache Airflow, or you could use any other mechanism. Just for example, here we are using step function, which will do the orchestration of these jobs. So that's the whole process. So as the data comes, we will kick the step function, which will go and call three glue jobs, which will in turn call DQ, or will have the DQ functionalities. We test the quality of the data and bring the results back into a central location. So that's going to be the demo. So if you're okay, I'll switch back to my console and start showing the demo.
I also will paste a link to that blog. I just quickly did the old search for it, just in case people don't want to, to search for it themselves. So it's just there. Cool. Let's see if I can make this a little bigger. I might have to actually hide myself.
You want me to zoom a bit?
Oh yeah, it's always good to zoom.
Is it better?
Yep.
Cool. So this is the S3 bucket where I have sample data. It's a sample data from United States legislations, right? It's available for you. So that's the data I'm using today. And we are going to do the quality check of this data using DQ, right? So this is a raw data set where my input data is coming. And once it is there, as I said, there is a step function, and we'll start this step function. You don't have to start this manually. In my demo, I'm doing it as a on demand, but you can schedule it and do a lot of innovations around this. So let me start and then talk about what's happening, because the entire process will take a minute or two. So let it happen in the background. So let me kickstart my step function. So if I go here, I'll start execution and say that, hey, this is my Glue database. That's where I have already crawled my data, the raw data coming from US legislations, and a couple of table names, right? So as I said, step function would go ahead and start calling those Glue jobs and start doing the magic. if everything works well, right? So let me go into the Glue Studio and start talking about how we use DQ in our Glue in this demo, right? So if I look at the first component, the profile runner, that's where it DQ goes. And if you remember, DQ goes and looks at the entire data set and comes up with a base statistic for your columns, right? So this is our Glue job written using Scala within Spark. And if you look at it, as you import any other library, you're importing DQ here. So I'm just highlighting here. Maybe if let me know if you can see, or if I have to zoom a bit.
I always zoom, mate.
Yeah.
Especially when text.
Cool. Yeah. So this is the code, and this is where we are importing the DQ component. And in that, we are saying that, hey, within DQ, load column profile runner and numeric column profile classes or the libraries. And once that is there, what we are doing is we are reading the data from the Glue. Here, there you go. So we already have the raw data loaded into the Glue, and we are reading that data into a variable. And finally, we are saying that, hey, Glue, do the profile scanner for my data. That's it. And the results are available for you. And as I said, results, you can send it to any downstreams. In my case, I'm writing that to S3 bucket here at the end, at the bottom. The second Glue job I would like to show you is the suggestions. That's where it's generating a set of suggestions. Before I forget, let me see. Okay, we'll zoom. So as I said, here again, this is a Glue job written in Spark. So we are importing all the required libraries from DQ. Same steps. We are loading the data from our Glue database and calling constraint suggestion runner class from the DQ, and that will start creating suggestion results for us. And this is the unit test for us, right? And once the results are there, you can write it to your favorite central storage. In my case, I'm sending it to S3 bucket, as well as we are sending it to DynamoDB because we want to build that user interface for the data stewards and owners. So it's flexible. It's only for the demo we are pumping it to 2 locations. And the last job, exactly the same, where it does the actual verification of the data. And same thing here, we are loading a bunch of libraries, classes from DQ library. It's a bit of a long code, but the concept here is what we do is we'll check the previous results from the suggestions or the data quality rules. We'll also get the raw data from the Glue and start calling verification component of the DQ. So that must be happening at the bottom of this code. So here you go. There you go. So this is where we do that. We call analysis runner from the DQ and pass the results. And once the results are there, you can use these results in a central location anywhere, right? So very easy, as I said, it's as simple as that, integrating open source library into your Spark code and using it in various ways. In this case, we are using it inside a Glue job, but you could use it in various other use cases as well. So let me see what is happening. Okay, good. What we are also doing at the step function is, if you remember all the results that we collect, we are also push that result into S3 bucket. So we automated the crawler as well so that it is available for you as soon as the data is ingested. Your data owner, data scientist, whoever wants to interact with data using Athena for ad hoc queries, it's available. So it's only that stuff. But let's look at what's happening behind the scene, right? So this is my DynamoDB. And all my suggestions, the unit test should be available here. So I'll show it in Athena so that it makes much more sense. And these are all the rules that it has generated based on the data, right? And if I go into my front end and refresh this, this is a UI. And as you can see, it says that, yeah, Casey, you have any?
Can you zoom in?
Okay, cool. Is it better?
Yeah.
Cool. So as I said, it generated set of suggestions for you based on your data. Things like, hey, a name is not null. There are quite a few rules on image files as well. What sort of images it can capture. and also classification and ranges for classification, like whether it has to be, should be between some values like party and legislator and so on. So it generated all these rules. And if I quickly go back here and show you the rules in the Athena, that will make more sense. It's still crawling, I guess. So let's come back to this in a short while. It will take 1 minute for the crawl as well. So meanwhile, what I'll do is I'm acting now as a data owner or a data steward. So my data has come, and DQ has done its magic and come up with this data suggestion rules. Now I'll go through this um, suggestions and say, okay, let me keep a few enable few of them. Again, it's not a rich UI. We just made it for the demo purposes. So I'll enable a couple of them, maybe classification, it's enabled. And also I'll show you adding a new rule so that you understand how everything works under the hood. So let me add a new rule called for the classification column. This time I'll say that, hey, my classification should have my name in it. Obviously, this is going to fail because US legislations will not have my name in their classification.
Oh, why not?
So, but the real focus is how DQ can find that anomalies, right? So I'm just creating a rule here and say create suggestion. Yeah. So I can also add analyzers. Now, there is a slight difference between suggestion rules and analyzers. Analyzers are, you can see things like you're generating some of compute level rules for your columns. For example, you're calculating some distinct count for a column, or calculating min max or standard deviation and things like that. So let me add one, then it'll be useful. The reason why we do it, the value that we get out of DQ, that can be used in your downstream steps to check certain things. For example, if classification distinct count is more than 2, then you can say, hey, I want to do some steps here because it's not valid, right? So let me.
Yep. So you use the field approx count distinct. What does that mean?
Yeah, it's basically, it says that it goes across the data set and identify what is the count distinct value of that classification, right? And it comes with the in this case 2, or in case, for example, I don't want to use that example. For example, if you have a gender column, you always expect certain values, or maybe priority column, you always expect 3 as a distinct count. You don't want to have more than more than that.
Oh, yeah.
Yeah. Now, before I'll kickstart my execution again, because I've now enabled few roles and I want to do the new execution. So let me start that and come back to the results shortly. So hopefully by now, my previous results should be, yeah, there you go. Previous results were available. Just to quickly show you some of the suggestions that it came exactly like what I shown in DynamoDB. It has come up with, hey, seeds should be non-negative, completeness, and ranges and everything. So this is how it comes. Now, Casey, the next run that I've just now executed, this will take 2 minutes. So what I did is yesterday, I just copied the same data and created a new, Glue catalog and Athena, so that I can show that results quickly rather than we all waiting for that.
Oh, yeah.
Right?
For the magic of preparing it twice ahead of time.
Yeah.
Yeah.
Exactly. And so that we can utilize the time better. So this is exact copy of the data. And I promise at the end of this demo, when my next run is completed, I'll show you the actual result. So if you look at it here, so if you remember, I enabled 2 existing unit tests suggested by DQ. I added one additional one, and that is classification should have my name, as well as I added one additional analyzer rule as well. Now let's look at how all that is coming up as part of the results. So this is my results. And if I go into results and run this check, there you go. So it has calculated this 3 results because I enabled 3 unit tests for my data. And if I scroll down right, I expect that one has to fail. There you go. The first one is failed and 2 others are success. Now, if I scroll on the left, So the first one is, that's where I'm saying that, hey, classification should have my name, and DQ has identified anomaly in that. Now imagine in your data pipeline, you can always, since you're getting the results back from DQ, you can always in your pipeline, you can take different steps based on, hey, what is the value of this column, which is constraint status? And if it is a failure, you can notify data owner or data steward, or take any other action. So that's how it works. So it has gone, suggested results, and we also modified or added any one. So let me look at this another one that we added, the analyzer one, and run this results. And we should have one for classification. There you go. So this one is calculated, which was not calculated before. So you can add additional analyzer or computational stats for your columns, which might be required for your business, right? And these are all works under the hood as a heuristic rules. And you can use this, for example, value of this column in your the next pipeline steps, checking, hey, whether the value is within the expected range or as per your business requirement, right? So these are the two things that I wanted to share. So if you look at it, the end-to-end demo that we showcased, data is coming, the raw data. Then we are running a bunch of glue jobs to do the DQ analysis. And DQ comes up and shows, a set of rules that it identifies, or a unit test that it identified based on my data set. It understood the data set and suggested, hey, Vish, these are all the rules. I think it's required for you to check your data quality. And we don't automatically apply these rules. We'll show the result as a like a blueprint for you, but it's up to you as a data owner or data steward. You want to enable them, modify them, or add new, which we have done that. And once you do that, it also does the verification for you. Now you have complete set of suggestions, you have complete set of results, and as I said, you can push that into a central location. And as you might notice, I'm also using Athena for later on ad hoc queries. So that's the entire process, how it works. And as promised, hopefully, yeah, this is completed. And I hope the glue crawler is also completed, because that is the one which it's just now stopping. Hopefully it's completed. And if everything is going good, then we should start seeing the values.
The moment of truth.
There you go. The same results that I loaded in yesterday's data. I just loaded so that if something goes wrong, always having a backup is good, right? So cool. That's the demo. Any questions there, Casey, or on the chat?
So there's no questions that have come through so far, but if you do have any questions around the demo or anything that Vish covered, just feel free to chuck them out there into the chat, and then we'll pick them up. In the meantime, while that is going on, I really want to touch on the fact that there's a lot of these type of services and solutions out there that I didn't even know about DQ until probably about 2 weeks ago, which is something that I should have actually been on top of a lot before that. And then there's one that's just come through with JSDF. Any way to make, say, a data quality dashboard based on the results?
Yeah, absolutely. The results are already in the S3 bucket, right? And I said Athena is there. You can easily push that into your QuickSight, or if you're using any other data visualization tool, you can use that as a dashboard. It's fairly easy because you already have the data.
As part of that blog, does it provide any QuickSight dashboards, or is it just kind of like
it's
saying
only,
that you can do it?
Yeah, you can do it. But yeah, it's a very, once you have the data, we can share a few links. Casey, I don't know how we can share the links after the event, or maybe we can add it in a description. So the whole idea of writing everything into S3 and also using Athena there, now you can easily, fairly under 5 minutes, you can spin up a QuickSight.
Yeah. So yeah, Bix is available through Athena or any or actually not DynamoDB because they can't connect to QuickSight. But any database, it would be pretty straightforward. Cool. And to continue on with that, but yeah, just feel free to keep checking those questions out. Just the time when you get access to two solution architects, just
Yeah.
throw questions out there. We're happy to ask. But like, yeah, there's tons of services out there, and always things to learn. And the training and certification side of things, like where we have got skill builder out there. So if you just Google skill builder, it will take you to a website they have where you can actually say, I want to learn more about this particular type of services, such as storage, AI, and all of that. And then it'll put together a learning path for you. Or you can say, I'm a systems engineer or I'm an architect, and then it will build out a training profile based off that job description. And it's all free of charge, all free content in there. We
Casey,
sorry.
one thing I wanted to share, if I'm still sharing my screen,
Yeah, I'll pop that up now.
yeah, if there are any data scientists or engineers wondering how we can use that part of machine learning, so this is an example. As I said, PyDQ is just a wrapper on top of DQ. So if you're doing a SageMaker notebook, so you can easily load your PyDQ part of your notebook, as I'm showing here. Like you create a Spark session and load your PyDQ in that. And after that, it's fairly simple, right? This is a column profile runner that I said, creating the column statistics. This is a constraint suggestion where you generate the suggestion rules or unit tests. So it's pretty much the same as I have showed in the DQ. Works exactly the same. It's only that you are using Python now, and the way you load inside a notebook is basically creating a Spark session. Just wanted to highlight that.
Yeah, that makes sense. That's very good. Cool. I will just make it going back to two talking heads, because the talking heads are always great. Yeah, so the reason I bring it up is because all of my customers and partners are screaming out for people that are qualified in cloud and all of that. And that's where that certification and that training actually really stands out, because it's absolutely just screaming out for help. And if you are in New Zealand or Australia and you do, I think you book in your test before the end of September and you do the test before the end of October, you can get 50% off if you follow this link here. I'm pretty sure I have remembered that correctly. But yeah, that's a good way to save 50% off. And if you can then harass your boss because it's an upskilling opportunity, then to pay the other 50%, then it's free. So that always makes everyone happy. Normally, I actually have a slide that has a whole bunch of other information on it, but because I only got a single screen, I'm at work, it's a bit of a limitation there. So I think this would be a good place to wrap it up, because I don't really want to drag this out. But Vish, do you have any last things that you want to say before we close out?
Not really. Yeah, just try using DQ. It's very simple and saves a lot of time, right? So
Yeah.
thanks, Casey, and thanks everyone. Really enjoyed sharing this session with you.
And thank you, Vish, for sharing your expertise and your knowledge with us and the stream as well. It was very informative. I learned a lot, and I hope everyone, by the seams of it, the emotes that's been popping up in chat over the course of it, I think everyone really appreciated it. So, yeah, thank you very much. And with that, I will bid everyone farewell. And let's see if... Catch you, everyone. Mate wa.
Thank you, everyone. Good day. Cheers.